students, and welcome back to another topic in science class. And this week, our topic is going to seem like we're going around in circles. Why? Because we are going to be talking about biogeochemical cycles. That is a cool title for a topic, wouldn't you agree? So why don't you say it with me? Biogeochemical cycles. Again, biogeochemical cycles. Biogeochemical cycles. Biogeochemical cycles. All right, it's catchy. Yes, I know. But what in the world are biogeochemical cycles? Well, first, let's look at the word. It's a long word, and it's made up of different parts. In fact, let's look at the parts here right now, and you may see the first part is bio. You probably know what that means. Bio refers to living things. Geo, you probably know what that means. Geo means the earth, refers to the earth. Chemical. Chemical is pretty much self-explanatory. Elements and compounds and so forth. These are chemicals. So put them all together, you've got life, earth, chemicals, cycles. What all does that mean? Well, as we will discover this week, biogeochemical cycles include the movement of elements and compounds through the earth, and not literally through the earth, but around the earth's surface, through living things. So we'll get to that a lot more in detail in the very near future. But first, let's talk about what cycles are. This is a little bit easier to understand. A cycle. A cycle is something that goes around and around and around again. Like if you think of a bicycle, bicycle, bicycle. I love to ride my bicycle. I like to ride my bike. A bicycle has two wheels. A wheel is something that goes around and around and around. The seasons of the year are things that come every year, and they come around and around and around. Your birthday is something that comes around every year. And when you get to be my age, they come around a little bit too frequently. And your age starts to increase a lot faster. But it's a cycle, repeats itself. Now, so there are different kinds of cycles. First, there are cycles that occur on a daily basis. They are daily rhythms. If we look at this lovely picture here, you will see the happy sunshine shining on planet Earth, and the Earth rotates on its axis once every day or 24 hours. And during the course of that day, certain things happen. For instance, some organisms on planet Earth are what are called diurnal. Human beings fit into that category. Our biology is set up so that we are diurnal organisms. A diurnal organism is an organism that is active during the day. Now, I know some people have to work the night shift and have to work all night long, but you know what? It's not natural for the body to do that. And if you know anybody who works the midnight shift and works all night long, you know that they're probably always tired, and the body can never really get used to being awake at night and asleep during the day. Our bodies are just not designed that way. If you were a bat, on the other hand, you'd come out at night and go to bed during the day. So there are different organisms that are diurnal or active during the day. And the converse, or the opposite of that, is also true, that there are some organisms on Earth that are nocturnal. That's probably a word that you've heard before. Nocturnal. Nocturnal describes organisms that are active at night. So diurnal, active during the day, nocturnal, active at night. Like I mentioned, bats are active at night, raccoons are active at night. And there are whole groups of organisms on planet Earth that are either diurnal or nocturnal. Now, there's a great way that I use to remember which one is which. Look at these arrows that I've drawn here. You might want to draw similar arrows in your notes and circle these letters. Diurnal begins with the letter D. Active during the day begins with the letter D. Day, diurnal, diurnal day. See what I'm getting at here? Nocturnal begins with an N. Night begins with an N. Nocturnal night, night nocturnal. That's the way I remember which one is which. You're going to have to remember it for your quiz as well. Maybe that'll work for you. But make sure you know the difference between diurnal and nocturnal. And so in the context of biogeochemical cycles, some cycles repeat over and over again on a daily basis. The sun rises and the sun sets as the earth spins on its axis and gives rise to different organisms taking advantage of different chemicals on the earth's environment, and things cycle through. Now, there's another cycle that occurs on a monthly basis. These are called the lunar rhythms. Lunar rhythms, you may recall our topic last week talking about lunar cycles. So we know a little bit more about the moon here this week. But here's the Earth and here's the moon. And how many of you remember, how long does it take the moon to go once around the Earth? Hopefully you said a month or 29 and a half days, because that's how long it takes. And it takes that long every month. And every month, as the moon goes through its different phases that we learned about in the last topic, different things happen. There are various types of lunar rhythms. These monthly cycles include the high tide and the low tide, the changes in moon phases from full moon to new moon. We learned about the details of that last week, but it also relates to how materials flow through the environment here on planet Earth, because there are many organisms. I'll give you one example: horseshoe crabs, for instance, or sea turtles, that base their whole reproductive lifespan on lunar cycles. Some organisms are more active during full moon phases than they are during the new moon phase. And so these materials in nature get cycled through these living things, biogeochemical cycles, on a monthly basis instead of a daily basis. But there are other cycles. Yes, there's another one: the annual rhythms. Annual rhythms. Here we have a picture of the solar system, and here's planet Earth, although it looks like it's upside down. Anyway, how long does it take planet Earth to go once around the sun? I hope you said 1 year, or 365 and a quarter days, because that's how long it takes to go around the sun once. And during the course of a year, we have these annual rhythms in nature that take place as well. Primarily, they involve the seasonal changes that occur as the earth revolves around the sun. Now, if If you were an organism and you lived in an equatorial region, in other words, an area near the equator, you don't really experience changes in seasons. And that's one reason why those areas are so biologically productive, because it's like summertime year round. And then there are other regions like where we live in a temperate region where we experience the change in seasons, winter, spring, summer, fall. And there are various organisms that are active more during one of those seasons than another, and other things happen. And then if you live in an Arctic or Antarctic region, you basically have winter and a very brief summer. And organisms that live in those regions of the world, they have to come out during the summer very quickly, do their thing before they have to deal with a long winter once again. But let's talk about some annual rhythms and how it impacts organisms on Earth. You may see, like this time of year, you may see flocks of geese, at least in the northern hemisphere where we live, in this part of the country. We're on the eastern fly path, and we see migration taking place on a large scale. Every fall, we see flocks of geese flying south, and every spring, we see those geese flying north. Why? It's because migration is taking place. In the example of the Canada geese, they are moving from breeding to feeding grounds. Canada geese typically breed in the summertime in Canada or areas to the north. Their shortened summers are long enough to raise their young and then teach them how to fly south for the winter, where they spend the winter in warmer places feeding up a storm. And this is the case with many, well, all migratory animals, whether you're talking about birds or mammals or fish as well. There are many animals on Earth that experience migration, the movement from breeding to feeding grounds. But there are other cycles that occur on an annual basis, such as hibernation. Where we live in this region, we have bears, black bears. And if the winter is cold enough and there's a lot of snow, the bears will undergo hibernation. They will seek a location where they can experience a winter resting state. The Latin word hibernus means winter, which is where the word hibernation actually comes from. So, hibernation is when an organism experiences a dramatic change in their metabolism, their body, on all of their bodily functions slow down. They're not really sleeping per se, but it is an altered state of consciousness. They are hibernating, they're breathing slower, they're digesting slower, they're doing everything slower in order to save their energy. And the reason they do this is because there's not food around for them to eat. So if there's not a lot of food around for them to eat, they've got to enter this winter resting state, or they would end up starving to death. And who wants to see a cute, cuddly teddy bear starve to death? Oh my. He's probably saying lions and tigers and bears. Oh my. All right. There's another type of resting state, and this takes place more in uh, drier desert climates, and it's called estivation. Estivation comes from the Latin estivus, which means summer. And estivation is a summer resting state. And there's plenty of organisms that live in desert climates that are plenty active during the winter when it's cooler. But when that summer sun comes out and bakes the ground, it becomes too hot for some critters to survive. And so they'll burrow under the ground where it's cooler and enter a summer resting state to stay cool so that they can survive, and their body systems slow down as well in order to survive an extended period of hot temperatures, which otherwise could kill them. All right, so we have discussed in general terms different kinds of cycles. And so I'm going to cut this video short for now. And I will say, as usual, for now, I'm going to say bye bye. But the daily cycle will repeat itself, and I'll be back. I'll be back. Bye bye.